Guru Busters!
Welcome back! In the last video we took Monte Carlo simulations in Excel up a notch and we saw how variance can lead to some wild betting results. If you are new here, stop and go watch the last couple of videos, because today we are digging into some serious stuff that builds on everything we've covered so far. We are answering a popular question. How many bets do you need before you know if you are actually profitable? I've seen all kinds of experts online trying to answer this, with people throwing out random numbers like 1000 bets or 2000 bets, as if it's that simple. Sorry, but that's complete nonsense. There's no magic number, no single answer. And here's why. It depends. And the biggest thing it depends on is luck. Yes, the old friend we keep running into. Here's the plan for today. We're going to run a Monte Carlo simulation in Excel with two scenarios. First, we will assume no edge on our bets. Just a break-even game where, on average, we neither win nor lose. This gives us a baseline that we can then compare against a scenario where we introduce an edge. With no edge, we will see how often we land in the lucky zone, that top 5% or 1% of results where we are very profitable purely by chance. Then we will introduce an edge and see how often we land in that same lucky zone with an actual advantage. Just like in the last videos, we are using generated odds for the simulation. But here's the exciting part. You're not limited to generated odds. If you wanted, you could copy your actual betting history into this spreadsheet to analyze your real-world performance. Or, and this is where things get really powerful, you could import data from your backtesting. That way, you can see if the edge you believe you found in backtesting has any real statistical significance. Let's start by setting up our simulation with no edge, where each bet is break-even. This means that over the long run, the average outcome is exactly zero. No profit, no loss. But as we've learned in the last two episodes, randomness will give you a spread of results from big losses to big wins. By simulating thousands of runs under the zero edge assumption, we will get a range of outcomes. Most of these will cluster around zero, but some will be outliers on the positive side, the top 5%, the top 1%, or the top 0.1% of results. We are calling these results the lucky zone, because this is where pure chance alone makes you look very profitable. As you can see, I have done some labeling and formatting in the spreadsheet to make it easier to follow along in the video. Feel free to do the same, but don't worry, there are no new formulas yet since last time. The formulas we will need are ones we are going to build together as we go through this step by step. Now we'll calculate the top 5%, 1% and 0.1% cutoffs. We will use Excel's percentile function. The range of our profit loss values, 0.95. This gives us a threshold for the top 5% of results. The same way for the top 1%, 0.99 and top 0.1%, 0.999. The rare outcomes that only show up because of extreme luck. We start with 100 bets. As always with our simulations, the values fluctuate slightly if we press F9. But as you can see, they are quite robust and we can work with them. So what do these values mean? If we are lucky, top 5% lucky, we end up with a profit of 1,798 or more. And if we are very lucky, top 1% lucky, we end up with a profit of more than 2,553. And if we are extremely lucky, top 0.1% lucky, we end up with a profit of more than 3,436. We will copy these values here as we need them again later. We repeat that for 200 bets, 500 bets, and 1000 bets. I extended the spreadsheet and can do it for 2000 bets as well. On my computer, Excel starts to become a bit sluggish now, so if you want to extend it further, like to 5000 or 10,000 bets, be ready to wait a bit for the results. So why are we focusing on these top results when we are running a break-even simulation? Because they give us a threshold to measure against when we introduce an edge in our bets. Here's the logic. If we run the simulation with an edge, and our results fall into the top 5%, 1% or 0.1% range, it suggests that we are performing better than we'd expect from chance alone. Let's break down what it means if we end up in these top zones with an edge. In statistics, we call these thresholds significance levels, which let us evaluate if our results are likely due to chance alone or if there's something more going on. When we talk about a 5% significance level, what we are really saying is that there is only a 5% probability, the p-value, that our results would be this good just by chance if we had no edge. If our results land above this 5% threshold, we are saying there's evidence to reject the null hypothesis, which in this case is the assumption that we have no edge. It doesn't mean we are guaranteed an edge, but statistically it's less likely that our results are purely due to luck. The same logic applies for the 1% and 0.1% significance levels. These are even stricter benchmarks, meaning the odds of hitting those levels just by chance are 1 in 100 or 1 in 1000. The smaller the p-value, or probability of being there by chance, the stronger the evidence that our results are due to an actual edge rather than luck alone. Back to 100 bets. These are our benchmark values, we copy them here again. And now we simply count how often our results are above these values. Count if our range, in quotation marks, greater than or equal to, then the end sign, and the cell to the benchmark. It should be about 5% as we have defined it that way and are still in our zero edge scenario. The same for the 1% and 0.1% benchmarks. Alright, now let's add an edge to each bet. Minus 10% commission rate as we did in the last video, a pretty fat edge for pre-play betting. Let's run it and compare. With that edge, we'd expect to end up in those lucky zones more often. And guess what? We do see more results in those top zones, but there's still a very high chance that we don't. What does this 3.13% value mean? It means that someone who actually has the edge we defined, but doesn't know if they really have it, can only reject the null hypothesis that they have no edge at the 1% significance level with a 3.13% chance. So basically, in most cases, this person can't conclude anything after 100 bets. We repeat this process for 200 bets. Copy and paste our benchmark values here. It looks slightly better, but still, you'd have to be very lucky to be able to conclude anything. Then we repeat for 500 bets, 1000 bets, and 2000 bets. Even here, if we expect a 1% significance level, in the majority of cases, you won't be able to conclude if you have an edge after 2000 bets. And even if you are happy with a weak statistical significance at the 5% level, we'd still be unable to conclude anything in about 1/3 of cases. But honestly, for example when backtesting a strategy, I would never rely on weak statistical significance at the 5% level. That's just reckless. You're basically gambling that you have an edge. Here's the bottom line. If you believe you might have a small edge, you need a lot of bets. Way more than the random numbers of people throw around online. So forget about 1000 bets or 2000 bets. The real answer to how many bets do you need is it depends. It depends on the size of your edge, the odds you are betting on, and how luck plays out over time. Now that we have built this spreadsheet, you've got a seriously powerful tool in your hands. One that opens up a lot of possibilities for testing and learning. For one, you can use it to analyze your own betting results. If you make a few tweaks, you don't have to stick with a fixed stake. You can put in your actual stakes and see how your personal betting record holds up under the microscope. You can also use this to backtest strategies or even test how profitable some tipsters really are. In fact, we might just do that in an upcoming video. But before that, there are a few fake gurus we urgently need to bust. So if you're enjoying these videos, make sure you hit like and subscribe so you don't miss out what's next. Until next time.
Guru Busters!